Hi everyone, I'm Jake, and today I'm going to show you how to make a character-based VR pawn for Unreal Engine 5. It's going to have smooth locomotion, smooth turning, snap turning, jumping, capsule collision, and it's going to scale the capsule to the top of the player's head so that they have to duck under things. And then this character blueprint that we create is going to be the base for a tutorial series where I continue to build upon it with features that you might want for your VR game. Editor Jake here. I forgot to mention that all of the project files for this video and my future tutorials will be available on my Patreon, so if you want to save some time and support the channel, it would really help me out a lot. Thank you. So, let's get into it. First off, I have just a basic VR template project here in 5.3. I'm going to create a new folder and call it Custom VR Pawn. And the first thing I'm going to do is create another folder called Input and set up our inputs and data types for the pawn. So first off, I'm going to create our input actions. So I'm going to do IA_jump. And we can leave that as default, a digital bool with no modifiers. Then I'm going to create another one for turning, and this one's going to be a axis 1D with a dead zone modifier. And then we're going to create one more for movement, and this one's going to be a 2D axis with a dead zone modifier as well. All right, and then I'm going to create an input mapping context. I'm going to call that IMC_custom VR pawn. All right. Now let's open that up. And I'm going to go ahead and copy my mappings over from my other project. All right, here are all of the inputs that I'm using for a wide range of headsets. For turning, movement, and jumping, go ahead and pause if you want to copy those over. And then the next thing I'm going to do is create an enumeration for distinguishing between turn types. So I'm just going to call this enum_turn types. And we are going to have smooth turning and snap turning. And this is just so you can more easily switch between them in the character blueprint, which is the next thing we're going to create. So create a blueprint class, character. I'm going to call this custom VR pawn _blueprint and open that up. All right, so the first thing I'm going to do is add a scene component and call this our VR origin. And this is what our headset and motion controllers are going to be relative to, so that we have an origin that we can move everything around and control where the play space is in game. So next I'm going to add a camera and our two motion controllers. This first one is going to be left controller, and it should have motion source left. Then we're going to add our right controller, and the motion source is going to be right. And make sure all three of those are childed to the VR origin. Next, I'm going to go over to the VR templates pawn so that I can steal the hand meshes from that so that we can have some hands for now. Eventually, I'm going to show you how to make a full animated avatar system, but floating hands will work just fine for now. I'm going to copy both of those and paste them here. The left hand can go to the left controller, right hand can go to the right controller, and then I'm going to make sure that their relative positions are still the same. And it looks like they are. So I don't think we need to mess with these at all. Okay, good. Lovely. Now I'm just going to move our VR origin to the bottom of the capsule component so that our player's ground lines up with the ground in game. Capsule half height is 88, so we're going to go to minus 88. Now, to actually use our pawn in game, I'm going to create a blueprint mode, game mode base. We're going to call this custom VR pawn underscore game mode. I'm going to set the default pawn class to custom VR pawn blueprint. And then I'm going to set that as the game mode override in our world settings. There we go. And now if I press play, it should use our pawn and our floating hands should show up once I turn my controller on. There we go. 2 working hands. And now let's move on to the rest of the features. All right, the first thing we want to do is add input mapping context so that our inputs will actually go through to the character blueprint. So the first thing I'm going to do is get our player controller, get the enhanced input local player subsystem. It's a bit of a mouthful. Then add mapping context. I'm going to select our custom VR pawn mapping context that we created and trigger that on begin play. So now we should be able to use any of those inputs in our character blueprint. So let's do turning first. So let's say IA underscore turn. Make sure we're using the one from our custom VR pawn folder and not the VR templates turning. So we created an enumeration to differentiate between the 2 different turn types. So I'm going to just add that as a variable in here, call it turn type, and use enum turn types. And we will get that. And by default, I'm just going to have that set to smooth because I like smooth turning, but I'm going to show you how to do both. So for smooth turning, we're going to use the triggered execution pin because we want it to fire continuously as the player holds down their joystick. And I'm going to use a switch on enum turn types node and plug in our variable and then add controller yaw input. So this will only fire if this variable is set to smooth turning. And I'm just going to take our action value. I'm going to multiply that by a new variable, which will be our smooth turn speed. And by default, I'm going to set that to 0.5. And that should be a float value. So we're going to multiply that and then plug that in for our yaw input. Now for snap turning, we only want it to fire once every time the player moves their joystick to the side. So I'm going to use the started execution pin, switch on enumeration turn types, plug that in, and then for snap turning, we're going to add a controller yaw input. And that is going to be the sign of our action value multiplied by another variable, and this will be our snap turning increment. And this will be the degrees by which you want the character to turn every time. I'm going to set that to 45 for now. And then go ahead and divide that by 2.5 because that's just the conversion for degrees to like controller yaw input. At least that I've found. And now, if we press play, are we on smooth or snap turning? Okay. Now if we press play and I move my joystick, there we go. We've got some smooth turning. And if I set it to snap turning, we should turn in 45-degree increments. 4, 5, 6, 7, 8. There we go. Lovely. All right. Now let's add our movement and jumping. So I like camera-based movement, so that's what I'm going to show you how to do. I'm going to take our movement input action, split that struct pin, and this way we'll have two different values for our X and Y movement axes. And I'm just going to have two different movement inputs because I think it makes it a little bit easier. And basically, I'm just going to take our camera. We're going to get the forward vector, and we're going to get the right vector. And then I'm going to split these, and I'm going to get a normalized node. I'm going to split that. And we're just going to use the X and Y values for these because we're just going on a flat plane, like we're just going sideways and forward, not up. So I'm going to normalize both of these, plug those into the different movement inputs, and then we can use the X value for the right vector and the Y value for the forward vector. And this should give us proper camera-based smooth locomotion once my controller turns back on. There we go. So now I can snap turn, smooth locomotion, and smooth turn. Lovely. And now let's add jumping. So I'm going to use our IA underscore jump. And you know, this one's a little more complicated. On started, we're going to jump. And on completed, we're going to stop jumping. Now if I press play, there we go. We've got smooth locomotion, jumping, and turning. Now, something you might notice is that if you... Oh, I forgot the charger was still in there. Okay. Something you might notice is that if you move in your play space away from your origin, your body is not going to line up with the capsule component. So like, feels like I should be able to move to the right here, but it's not letting me because the capsule is in front of me hitting that. And I'm also not turning around the center of my body. I'm turning around the capsule. So next thing we're going to do is offset the capsule so that it always stays beneath your head and you can have that play space movement and play space collision. So for that, I'm going to come into our character blueprint and I'm going to use event tick because we're going to offset the capsule every tick. And I'm going to create a function and just call it offset actor to HMD. And we are going to take our capsule component. We're going to add world offset. And that's going to be our camera's world location minus our capsule component's world location. And I'm going to go ahead and split these struct pins and only use the X and Y because we don't want to offset it in the Z at all. We don't want to, send the player flying into space or below ground. So we're going to add that offset to the capsule component. But because the VR origin, which controls, the camera and controller's location, is a child of the capsule component, we also want to do the inverse of that offset to the VR origin so that your actual camera isn't getting offset, just the capsule collision. So let's negate that vector and then add that world offset to our VR origin as well. That negated offset. And I'm going to unhide the capsule component. I'm going to uncheck hidden in game just so you can see how it's moving with us. And it does not seem to be working. That's because I didn't plug it into event tick. Event graph, let's make sure that our function is plugged in. Now the capsule will move with us side to side and forward and back. And we can still move around with our joysticks and controllers and hit walls and all those good things. I should change the step up height, but like if I try to walk through a wall, it won't let me. There is something I can change to make that a little bit better. If you change the world offset on the capsule component to sweep, now if we press play and I try to walk through the wall, it smoothly pushes me away from the wall even through that Playspace movement, which is really nice. And now I shouldn't be able to step up onto this table as easily either. Nope, just pushes you away. Lovely. So, one last thing we have to do is make it so that the capsule scales down with you. So, I'm just gonna duplicate that and drag it over here to show you. Right now, the capsule is not scaling with our head, so even if I were to try to crouch below this, it's not gonna work. You can see the capsule is still all the way up there. So I'm gonna show you how to change that. So first thing I'm gonna do is create a new function. We're gonna call this scale capsule to HMD. And we're gonna use a set capsule size node for this. So for the radius, we'll just get unscaled capsule radius because we don't want that to change. All we want to change is the half height. And that's going to be our camera's relative location, which is just going to be basically your height, your eye height above the ground in the real world. We're going to take the Z and we're going to divide that by 2. And that's what we want the capsule half height to be. So it lines up with our eyes. But then once again, we're changing the capsule. The VR origin is a child of the capsule, so we're going to have to account for that. So we're going to take our VR origin and set its relative location to account for the change to the capsule component. So the X and the Y can stay the same. So I'm just going to get the relative location, split it to use the X and the Y, and then the Z is going to be the negative of that. We're just going to multiply it by -1. And then I'm going to subtract 2.15 units from that for our Z location. And the reason I'm doing that is because Unreal Engine's character blueprint has about a 2.15 unit gap coded into like the capsule collision. So it's always just a little bit, it's always 2.15 units off the ground, the bottom of the capsule, which is fine for most gameplay. But in VR, you really want your floor in game to line up with the floor in the real world so that it feels more natural and it doesn't give your players motion sickness or anything like that. So adding that, making the VR origin 2.15 units lower actually keeps the ground in line and it's a little bit nicer. So that's something I like to do. And now if we press play, we have turning, locomotion, collision, and if we crouch down, nothing's gonna happen because I didn't actually put the function on event tick yet. Scale capsule to HMD. All right, so now we should have a fully functioning VR pawn with smooth turning, snap turning, smooth locomotion, Playspace collision, and as soon as I crouch below this, it should let me underneath. So I'm just holding down my forward button, but it won't let me go under until I actually get under it because you can see the capsule is now scaling with our headset. Lovely. We've also got jumping, and I think it's a pretty nice, flushed out character pawn for VR. So thank you guys so much for watching. Again, project files are on my Patreon, along with the project files for all of my future videos. Next video is probably going to be network replication. I'll show you how to set it up with multiplayer so that the player movement is replicated. Then I'll probably make another video showing you how to optimize that really well. So thank you all for watching. I hope it was helpful, and I'll see you later. Bye.